its boost back. Real excitingly, though, we've got 6 out of 6 Raptors lit on ship there, so it's now going to continue to make its ascent into outer space. See the engines throttling down.
Booster engine cut off. Ship ignition.
Stage separation.
Use back burn startup.
All right, successful hot staging maneuver. So we've got 12 of the 13 engines lit back up. Less than 30 seconds to go in this ship ascent burn. All right, RVACs have shut off. 3 more to go.
Ship engine cut off.
All right, all ship Raptors have shut down.
Nominal orbit insertion.
Here we go.
Oh, Raptor ignition. And shut down.
All right, there was that Raptor relight. Looks like engine 3 full duration. As Dan mentioned, that's a 3rd attempt, and we just did it 3 times in a row. So congrats to the team, the ship team, Raptors. Yeah, and that blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. V3. So yeah, Starlink provides us with one more path to collect data and help us rapidly iterate Starship's design.
And if the ship does manage to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or 5 miles per second. At those insanely high speeds, the spacecraft moving through the atmosphere creates a plasma field around.
I mean, we're using Starlink to bring all of this together. It's our drone shots you see here from our great team down here at Starbase, all connected. So Starlink not only giving us cool views off the planet, but also on the planet, help bring everybody along for all these Starship flights.